Oh yes, ladies and gentlemen, I remember telling you the other time that I would be able to give post at least a software. There is a program in the month of February before March, but I didn't manage to do the posting, not because I did not do anything constructive, but I did some program, although they were not much pleasing to me, and therefore I decided not to post them because they didn't meet the standard that I expected of me. So in the month of January, February, I managed to do some algorithms where I program uh, 3 or 4 algorithms, which I'm not going to show them here because they're not in the point of interest. They are in. I did do the programs out of net, and therefore then the other machine of mine, which is not with me right now here. And today I'll only give a breakdown of what I've done with the Kaggle, that is online cloud. So in the month of January, maybe to let you know what I've done, as I promised, the month of January I managed to do a program. The first program I did was on e-commerce, where you could use kind of machine learning profile to do a planning, really for not really planning, but to manage the transactions, where you can use whenever you want to do an upscale or maybe prices of a product or products, or you want to give a discount, then you could use that software to do a bulk of spreadsheet problem, maybe a spreadsheet data within a second. Because whenever you want to do, maybe you want to give a discount for a product or products, then you have them in a spreadsheet kind of format, then you are able, and you say that in the CVE, then you're able to that kind of software would allow you to do it within a click at the button, because a click on the button, because doing it one by one will take time and will perhaps cause a lot of inaccuracies. Then I also developed some kind of a gambling kind of software where 2 or 3 or 4 people could gamble free without any prejudice. Then I developed a Django, a website. I also developed a website also that could be used by the marketers. You can post your maybe your stuff in that market, and then in that platform, and then you'll be able to get okay, customers or clients are able to access it from there. Then I went further and created kind of a software or a program that could inform the nature of the market, where could at least the marketers or the entrepreneurs would use to inform on what product are they supposed to sell with depending on the location and the potential customers. Like it was kind of the age, like this kind of a product, the middle age, maybe they use this program. Like for instance, Lashum, now you want to do a business in kind of maybe the snacks. Now you see there's some old says who like one type of a snack and the others that do not like. So that kind of program would be able to inform the decision for the marketing. Now again, I did a bit of segmentation in the tumor segmentation that I was doing with the liver. But today I want to bring you a process of brain tumor classification, where in classification you understand this now is not something much different from detection, because for it to classify, it must detect. So this kind of a program that I want to show you for is kind of a program that is able to detect tumor and do classification. So this one I'm going to use a Kaggle platform where I'm going to obtain my data, although data must not be obtained from only Kaggle. You can obtain your data either from Decathlon, that is medical Decathlon, or in full. If you want to get the data, you just Google medical Decathlon, or you can go through long way, you write medical segmentation Decathlon, or you go to Cancer Imaging Archive, or you can go to the MONAI. MONAI is a medical open network for artificial intelligence. But if anybody who is going to do anything artificial stuff must have a knowledge of how MONAI works, for you to do proper work. So I obtained my data from Kaggle. I downloaded my data from Kaggle. As you can see, I have a Kaggle notebook up here, and then the name of my program, of my project, is brain tumor classification by Omosh. Omosh is nothing other than my name, project 1. Now, while obtaining the data, you can obtain the data in two ways. If you have the data within the computer, then you can upload. But if you want to get them direct from the Kaggle, then you add input. Now I added input because I was not obtaining the data from my own storage. So when I added input, this is the data that I obtained. This is the data, and then we have the data was composed of testing. This data here is supposed to be used to test the training, and this one we were supposed to use. I was to use this data to train the model, so that it becomes capable of at least doing the prediction. Now, when you check on the testing, we have, as you can see, we have 4 types of files. The file 1 is glioma tumor, we have meningioma tumor, then we have the no tumor, then we have this other one called the pituitary tumor. So these 3 types of tumors are tumors that resides within the brain, and therefore after the program has been developed, we expect the algorithm to be able to predict whether the slice imposed on it is either having a tumor or doesn't have a tumor. But now, in an event, if it has a tumor, then we expect it to classify the tumor. It must not just say that the tumor detected, but it must tell us the type of the tumor, either it is a glioma tumor, meningioma tumor, or pituitary tumor. So in that, we proceed by, okay, before I proceed, I can give you the type of, you can see the glioma tumor is having this number of files, which will go up to, I think, one something files. There are very many files down here. There are very many. So they go up to, and you can see 70 more. There are very many files. I think they are 105 files. Yes, there are 105 files. So from there, you can allow me to minimize it again. Can allow me to do the minimization, and then as well I minimize this as well, and do the minimization here equally. So we come over here for we start the process. Now when you start the process, after opening the Kaggle, this kind of note will be there, so it's something that will become automatic. And then after loading the data, or after adding the input, then there's something that when I expand here, you'll be able to see. We have these ones, the tumors will appear here. As you can see, they will appear there. As you can see how many they are. So you can see the not really, let's just excuse a bit. You can see the train. You can see we have you can see they have the classification. We have the MRI, they are written, the input is brain tumor classification, MRI training. And as you go down, you will find testing also down there. Those are for training. Go for training. Then we expect to have some testing. Yeah, testing. You can see now we have testing down here. We have testing. These ones are now testing. As you can see, we have testing now down here. These are testing. So these are the set of data that we have obtained, and then you can allow me to do the minimization to see if I can minimize it so that I don't scroll so much a lot. Let me see if I can minimize it from up. If you will allow me, maybe. So it's a lot of data. As you can see, it's not a small data. It is very many data that resides within those 3 files. There are very many data. But you can't, don't mind, can, it's there. Okay, now, no, really, run it again. Shit, it's not willing to minimize, so we can still proceed because it's not going to affect us so much. Although I didn't want to move this far, it's moving so fast. Now, so to start with, we import some libraries, and these libraries are going to help us in doing the importation of the directories and the understanding of the directories. As you can see, we have the Keras. This is a library within this Kaggle, and it resides within the Python. Then we import these libraries. We have Keras, we have the kind of because from Keras we are able to import the sequential. We can able to convert 2D, this convolution 2D. Then you have the flattening, we have the dense, max pooling, and dropout. Because max pooling, dense, and this one we are going to use particularly in the development of the algorithm or the model. Then we have sklearn. Also, from sklearn, which is another library, we are able to develop to get an accuracy score. So here also it's just the same thing. Also, importation of libraries for creating the external image data. The same libraries that we are still using there. So then from there we go to the importation. We import the library. We go to data, path folders, or folder paths. So the folder paths, we create a string where we have x and empty string, then y, then we choose a size of 150. We choose a size of 150 for choosing a size of the image size of 150, and then we import the labels within the files where the labels are. The first one was glioma, then we have meningioma, then we have the no tumor, then we have the pituitary, just like these things that I had shown you here down here. As you can see them, we have glioma, meningioma, and no tumor, and then pituitary tumor. Now from here, I hope we'll still come back there and do some and explain some indexing. Now after importing this, then we are supposed to bring to feed the directory of the training, both the training and the testing. But now in many events we do the training part, and then you're supposed to do the training, and then we use these ones for the testing. But in this event, what I want to do is to merge the two, because I want the data to be as many as possible. I merge the two, and then I automatically split the data into two after shuffling the data. The shuffling, I will use the shuffler, which I have a directory that's going to help me in doing the shuffling down here. And in doing the shuffling, I will be able to get as many data as possible, and that is why you can see I have my directory for the training, and then I have copied all these things down here, and then instead of now training, then I have testing. It's going to merge everything, and then increase the number of data, and then we do the splitting. Now after that, then you come down here, then as you can see, then this one's the train. We give a command, and then we have 111. You can see now we have x train comma y train is equal to shuffle x train comma y train random at random state of this one. So this one I've chosen 111 to make sure that the shaping is the shuffling is perfect. And then you can check the shape of the that you expect, and when you check the shape, as you can see the shape here, you just use the x train shape, then you'll be able to see, as you can see, the shape is 3264, and then to 150 by 150 and times 3, because it's a 3D kind of directory. Then you get the split test. Then this one, train split test. Now this is where we start the kind of we bring in the parameters that are important for the training. And now these are the parameters that we have. You can see why train new, this one. So after doing that, we come to, after doing that, then we append everything. We append every the directory, and then we use the utils for those who are utils categories for those who are doing the algorithm things. Those who are in the machine learning are able to understand, but for you, if you don't understand, you can follow, you can go further and Google and understand what is there, because really this thing is not meant for the it's not meant for the soft-minded people. You can just get entertainment if you wish. Now here we have we come to the convolution neural network development. Now this is my model. Remember, I stated the sequential. I did import the sequential there. I imported the convo 2D. I imported the max pooling and the dropout. So these are the things that we are going to use with the activation of the ReLU, as you can see. And then I chose the shape to be 150 by 150 by 3. And then because 150 by 150, that's the size of the photo. I expect them to be what? To be 150, kind of a square, kind of on the face, but then we expect the 3D to be appearing in the 3D. Then we move this one. As you can see, where I've developed my model, I have the convolution, then I brought in the max pooling because I expected it to be a bit unique. Again, convolution, then the dropout. Then I have convolution, dropout, max pooling, dropout, and then I went to the convolution, then max pooling, and then dropout. And there's one thing that you also need to realize, that when I was doing this, I was trying to increase the width. As you can see, this here the width is 32, then I have 64. Of course here it's still 64 because I just copied this, but then down here I increased it to 128. Then down I had 256. So that one is just to make sure that my model is more complex enough to make sure that the training is properly done. As you can see, then we do the dense. I chose to use 512, and with the activation of ReLU, and then we have the dropout. I use the dropout. I gave a figure of 0.3 all through, and then we have the activation. I had a dense of 4, and this 4 was because I used this 4 because when you check the 4 comes as a result of the not directory though, but the files that are within this directory. As you can see, we have glioma, meningioma, no tumor, and then pituitary tumor. And maybe to explain further, meningioma, in terms of electronics indexing, meningioma is going to appear to be index 0. Then we have no, glioma will be index 0, meningioma index 1, no tumor index 2, then we have pituitary being index 3. That is how we expect. So when you start counting 0, 1, 2, 3, but in the real sense there are 4 files. So this has come about, and then we go to modeling. We run the model, get the summary. When getting the summary, you can see, but what is more interest to us is the paragrams. As you can see, the total paragrams is something much bigger, 4.889 million. As you can see, that's the paragrams, and then this is the total, and then this total is again the trainable, meaning our model is well, and it's I'm hopeful that is capable of giving us a appropriate result or accurate result. And then we do the model compilation. We compile all this. We do the compilation of all of the model. We compile them in a file. Do that compilation. After doing the compilation, then we go to the training. We train. Now when training, we use the command history dot model fit x train y train, but we have to increase, or we have to include the epochs, and this epochs is the number. These are the epochs. You can see epoch 1, epoch 2, epoch 3. So you must not have much bigger epochs, and you must also not take smaller epochs, because bigger epochs will make computer take a longer time before it does the training, and a smaller epoch, assume now you take epoch 5 year, then epochs 5, it means that the end result might not be so desirable, and a split of 0.1. So this is how this is where now we are splitting. we are splitting the train and test. So a split of this, so that 90% will go for the training, and then this one, the nini will go for the validation. 10% will go for the validation. As you can see, these are the epochs. As in explaining the epochs, you can see the epochs. This is the training accuracy. Then you have validation accuracy. Now in the training accuracy, we started by 28% accurate, and then we have validation was 27. Then you can see the loss was 3 here. Let me expand my screen. Then the loss here was 1. Validation loss was 1.36, but our point of interest is not there. My point of interest will be down here, the 20th epoch. Now at the 20th epoch, you can see my accuracy lies at 92. That is for the trading. Then you have a loss of 0.01, although this is not much pleasing to me. I expected something more better than this. And then we have validation of this, of validation accuracy of 89.8% with a loss of 0.2. This is also not pleasing, much pleasing to me. I don't like it. Then this one should not worry you. This is just a saving command that I used to save those models. And then we import the Matplotlib. This one will help us to do the plotting of validation accuracy vis-a-vis to the training accuracy, and validation loss and vis-a-vis to the training loss. So the first graph here, because we use this command here now, the first graph here gives us a graph of we have the blue kind of a line gives us, blue color line gives us what? Validation accuracy, and while red gives us the training. As I can see, it's not much, the deviation is not much, but I can still see some specs that really don't look pleasant to me, and therefore I still commit that I would be able to do much more advancement of the same. Now when you go to the other graph, that is the loss, we have the training loss and the validation loss. As you can see, the validation loss decrease as the training continues, while this one, the accuracy increases. It increases as time goes. So that one tells you that the program is not that much respects the algorithm modeling law. And then you can see this also saved it, and then from there, after saving it, then we now go to the prediction. Now when doing the prediction, you now insert whatever directory you want to predict, the directory of the image that you want to predict at here, and then also copy it here. Now for this case, I used 101, the pick number 101 for the pituitary tumor. Just like I said, that these things are going to, the prediction results will come in terms of index. Now when I did the predict that one, the result that came here was index 3, meaning it was pituitary tumor. Now let's try to do a prediction now. Now to do a prediction, what we do, we go to our files and we use training. We don't use validation. We go to training and then we open the one that was predicted with the pituitary tumor. But now I want to start from up here. I want to start from glioma, and I said that glioma will always give us it should be what I expect from the prediction is supposed to be index 0, to mean that the tumor has been detected, but it is a glioma tumor. Now to do that, we come to glioma and then open it, and then you can choose a picture of your choice. Like I've chosen this one of 4. Then you copy its directory, then you come and paste it here. You paste it here. You come and paste it here. You paste it here. Let's have Control V. Then also you again come and paste it here. Remember, we have taken glioma, so we want to check if it will give us index 0. If when it gives us index 0, then we'll be home and happy that our model is capable of doing the prediction. Then we can run this. Let's see if it will be able to upload. Yes, it has uploaded. As you can see, it has uploaded the data. Now, having uploaded this data, then we come to prediction. We come and run the prediction to see if here will give us index 0. If it will give us index 0 here, if we get index 0 at this point, then we will be sure. We will be sure that, oh, it's not giving us 0, it's giving us index 3, which is not nice. Yeah, I know where the problem is. We have uploaded, but we have not uploaded this image. What is there is still there. What is there is still what we upload the image, which we have done now. Then we come and run this. Yes, after running that, then of course we have uploaded it here, but we can still do the running because they co-depend on each other. Yeah, it's still the same. Then we come to prediction. Come to prediction and do our prediction. Index 0, as you can see, is now index 0. We have an index of 0 here. So this one tells us that the kind of tumor that is here, this tumor that has been detected, is not a meningioma tumor, neither is it pituitary tumor, but is what? It's a glioma tumor. Now, let us go to index, maybe we skip. Instead of that, let's take a picture from no tumor. I've copied no tumor. Then again, you come and paste it in these two. Paste it here. Paste it here like that, and then again you come and paste it here. You want to check if it will give us index. Remember, we have taken index 3, not index 3, but index 2. We have taken index 2. Let's see if it will be able to give us index 2. Then after doing that, as you can see, we have taken this one, tumor. We have classification, MRI training number, no tumor. We have taken no tumor, and just like I had said that, let me even use this testing. I've said that this one is index 1, index 2, index 3. No, index 0, index 1, index 2, index 3. So we expect an index of 2. So we come and run this. We run this to give us the shape. After receiving the shape, then we activate this. After activating that one, then we move and download or upload. We upload that the screen. It has uploaded it, as you can see. Then we go to the prediction direct. We predict. So as you can see, it has predicted 2, and 2 is, this one is 0, 1, 2. Our 2 is no tumor. It means that our prediction is good. As you can see in the directory that we have fed here, is no tumor. So we can move to we can check on meningioma tumor. Take either of the picture again. Then you come here and post it there, then here as well. Wash it. Then yes, then we run this. The sequence continues. You do as we are expected, just like that. Then you come to this, then you upload that pic, upload that kind of it has been uploaded. As you can see, the difference there, it has been uploaded, and then now we are free to do the prediction. When you come to the prediction here, activate prediction. Then after activating the prediction, and then you predict. Prediction, we expect it to be index 1, because remember it was meningioma. If you check here, it will be a meningioma tumor. So this one is able to predict from the data that was fed from it. It's able to check on the data and then predict, give us the result. Just like if you do the pituitary tumor, somebody will be skeptical enough to ask why I have not done the pituitary tumor. So let's do pituitary tumor, copy that, and then you come and paste it here again. Paste it there again. Do the same up.